Traceability is enabled by proper implementation of the PLM platform. And this is very critical because, as CEO of Aras likes to say, proper implementation of traceability is all about keeping CEOs out of jail. Imagine a car that fails. We have many examples of that in the industry. And then the immediate problem becomes, well, is that a problem with this specific car, or with that family of cars, or with that platform of cars? And it's very difficult to determine that unless you can trace back all the decisions and all the relationships that influenced how that car looks in the field. So traceability in today's world has a lot to do with digital thread and digital twin, because traceability is what enables digital thread, and digital thread is what enables digital twin. And here's a good example how all of that interplays. Again, if you take into example auto industry, and you take your own car that you're driving, what's in this car and how that car behaves is influenced by how it was designed, where it was manufactured, what options were added by the dealer, and then all the maintenance things that were performed by that car since it left dealerships. That makes your car very unique, which means that everybody's car is different from everybody else's. And in case of a problem, it is not realistic to ask manufacturer to keep track of all the possible implementations of cars out in the field, because that just becomes too big. You cannot have a digital version of what's out there for every single car. So that's where the traceability and digital twin come into place, because based on the serial number of your car, now you can recreate the history of what happened to that car. That's the digital thread. You go back, okay, these were all the maintenance factors that were done. These were the tires that were replaced. These were the manufacturing updates that were done. These were the options that were put on the car. And you can go all the way back to the system model of that car, and therefore you can recreate digital twin of exactly what's out there in the field. So digital twin is recreated when it's needed. It's never kept for everything. It's in that sense, it's dynamic. It's recreated when it's needed. It's recreated because the digital thread allows you to trace back all the relationships and all the events in the life cycle of the car, through its life cycle, through its manufacturing, through its design. And of course, all of that is enabled through traceability within a PLM system, where these relationships are appropriately configuration controlled. Now, what I just described is somewhat of a utopian scenario, but clearly that's the target that everybody's trying to achieve with today's complexity of the cars. And that's the relationship between digital twin, digital thread, and traceability. Traceability comes from PLM configuration management. It enables digital thread, which enables to build digital twin. Aras platform is particularly well suited for considerations of digital thread and digital twin because its configuration management engine establishes traceability between all the affected elements of the system as system is designed, and then a product as it is implemented, as the system is implemented. And if the flexibility of modeling the type of information becomes critical as the focus of design industry changes from mechanical widgets to highly complex behaviors and abstractions of the system, as opposed to how a screw would look. And without flexible platform, which allows to model on demand, introduce these new concept of what actually needs to be traced, it is almost impossible to create a vision for proper digital thread, which would result in a proper digital twin.